one of the super important things that's going to show up significantly later in this chapter are factorials. We're really going to need to be able to simplify factorials. Most of you probably know what a factorial is, but in case you don't, we'll run through it here really quickly. A factorial is written like this. 5 factorial means that you take 5 and multiply sort of successively by the next lowest term, and you continue doing that until you get to 1. So 5 factorial is 120, right? 3 factorial is 3 times 2 times 1, which is 6. The most interesting one in there is 0 factorial. 0 factorial, it turns out, is 1. This is something that's done by definition. I don't know that I have much of a good reason for why this is. I mean, I suppose I do, I just don't want to take the time to go into it right now. If you really want to know about it, talk to me during class and I can give you a few compelling arguments for why 0 factorial is 1. But for the moment, the mechanics of factorials are these things. So in this next slide, I'm just giving you the first 9 factorials, between 0 factorial and 8 factorial. This is sort of as far as I reasonably have memorized. And it serves me very, very well. It's worth your time to sort of sit down and look at all of these and at least get from 0 to 7 stuck in your heads. And actually 8 factorial I kind of have memorized just because this is an easy thing to multiply by 8 in your head. And that's an important thing to recognize. Like if you wanted to know what 9 factorial is, you don't need to do 9, 8, 7, 6, 5, 4, 3, 2, 1. If we know that 8 factorial is already 40,320, then 9 factorial we can get by taking that and just multiplying by 9. Right? And so if you feel like multiplying that out, you can certainly do it. Turns out it's 362,880, but I don't have that one memorized. It's not necessary. Get these ones in your head, and you'll be in good shape. So one of the really valuable skills at the end of this chapter is simplifying factorials, right? And especially after that last slide, you may very well look at this problem and go, oh, okay, 5 factorial is 120, 8 factorial is 40,320. Oh no, how do I simplify this thing? What I would rather us see is well, wait a minute, 8 factorial is 8 times 7 times 6 times 5 factorial, like times 5, 4, 3, 2, 1. And 5 factorial is 5 factorial. The reality is I can divide 5 factorial out of the numerator and the denominator. And all I'm left with is 8 times 7 times 6. And so if we multiply those things out, we end up with 336, and we can find that this expression is 1 over 336, right? But we did that by using and manipulating the factorials we had, not by working with a really large problem to deal with. So here's another example for you. Simplify the expression 10 factorial over 5 factorial times 4 factorial. Try this one out. There's a little bit of a trick on this one, but try it out, sort of see what you come up with. So my thought here is that 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 factorial. Then we'll have over 5 factorial, and I'm going to sort of stop here in the middle of my thought process. Right here I can see the 5 factorials are going to divide out. Now the 4 factorial that's left over is not like directly going to divide out like that. But if we write it out as 4 times 3 times 2, and I guess I'll put times 1, we can sort of see like, okay, I can see here that the 6 in the numerator will divide out with the 3 and the 2. And the 4 will cause the 8 to sort of be divided out to be a 2. And now all that remains is for me to multiply out my 10 times 9 times 7 times 2, right? So these two things will multiply to be 14. 14 times 9. So we end up here with the 126 times the 10, so 1,260, right? So we sort of used a combination of one of these factorials could be divided out in its entirety by using the exact same thing, and the other numbers we can divide into the other factors that you have in the numerator. So this is one last example that I have, and it's not, this is sort of not a directly useful thing later in the chapter, but I thought it was something that was sort of worth discussing. The thought is sort of like, what can be done to simplify this thing, right? And my thought is, all three of these terms, the 7 factorial, the 4 factorial, and the 4 factorial, they all share the factors of 4 factorial. So if I were to divide 4 factorial out of all of these, I would in some sense have 7 factorial over 4 factorial minus 4 factorial over 4 factorial, which is 1, all over 4 factorial over 4 factorial, which is 1. And I didn't really need this 1 in the denominator, but this one is fairly important. Now over here, 7 factorial over 4 factorial, that's going to leave me with 7 times 6 times 5, and then we'll have minus 1. So this will be 30. 30 times 7 is 210. 210 minus 1 gives me 209. I just thought of one more example that I would really like to show you guys, and so I'm going to do it very, very quickly. The idea is this. What happens if someone asks you to simplify something like n factorial over n plus 1 factorial? Right? Like, what do those things even mean? Right? And so I'll go through it quickly. N factorial would mean take the number n and continue to multiply by numbers that are 1 less than that until you get all the way down to 1. Right? Well, what does n plus 1 factorial mean? Well, it means start with n plus 1 and multiply by numbers that are 1 less than that. So 1 less than n plus 1 is n, 1 less than that is n minus 1, 1 less than that is n minus 2. Do that all the way down to 1. What you should notice here is, hey look, these will divide to 1, these will divide to 1, these will divide. Like, every number that we have here is going to drop out with the exception of the n plus 1. And so this factorial expression can be rewritten like that.